Hey everybody, going to go over constructors in a quick primer. Constructors are going to feel very similar to us, very familiar. And that's because whenever we have declared and then initialized a variable, an array, and anything that we've been working with so far, we have created the object and then we've given it some data. If we had like int value equals 40, well, we're creating the variable value and then we're assigning the literal 40 to it. Well, that's sort of a constructor. It's creating an entity and then giving it some data. Well, a constructor is going to do that same thing for us with objects. When we create the object, we can also give it the necessary data to populate the object right at the start. What this does for us is it allows us to not have to use all of the various mutator functions that we define in our class in order just to get data into the object. We can simply inline do the data or the object declaration and then provide it with a list of data that then is going to populate it. So let's take a look at what this really means. I'm going to go to my whiteboard here and get this shared. And let's remember that you might remember in one of our sessions, I just kind of pointed at some object in my house and it was a chair and said, oh, let's create a chair class. So this is going to kind of leverage that idea. I'm going to create a class just called chair. And when we create an object, we have a couple of options. Before, we could just simply declare a chair and then later do the various methods that might set the chair data. How about like set legs, if we're going to set the number of legs, or set cushion, if we're going to say that it's a cushion chair or not, maybe it's a hard chair. Maybe set color for the color of the chair. So you get the idea here. This was the only way we've used so far to populate our object with some data. But a constructor is going to let us do this in just one instruction. Now, probably not surprisingly, we've been using constructors all along, and that's because every class by default has a default constructor. And that sort of makes sense because we've actually created objects. So at some point in that creation process, some constructor must have been called. And it's just the default constructor that every class comes with. You don't see it in your code and you don't have to wrestle with it. If you were to pull open the hood and look at the engine, you'd see that this default constructor is there. We're gonna do the same thing in our code. We're gonna create some constructors. Now we can do a single constructor that is gonna then demand all of the data to be added to the parameter list. So let's start with that first. So let's say we've got this chair class. And if I've got, this is our chair, I'm just doing kind of whiteboard notes here. This is not valid C++ code. Let's say that we've got a couple of variables. We've got an integer for legs, and we've got a Boolean for cushion. And then we've got a string for color. So let's say that these are the private member variables here, an integer, a bool, and a string. Well, when we create an object of type chair, we can now provide an initialization list. And that then is going to put data behind all of these, again, rather than having to use our various mutator methods. So if we were to say chair as an instruction, chair, and I'll call it, how about chair dining room, dining chair. And then if we gave it an initialization list here, like this, this looks very similar to how we might go about declaring a vector, or declaring an array with some data, or declaring a structure object and giving it some initialization data. So what we're going to do is we are going to write code that then is going to take this kind of a statement with all of this initialization data. I'll call it an initialization string or sequence, because it's got the member variables listed in order. We're going to write code then into our implementation to figure out, well, how do we do this? How can we get this constructor written? After that, we're going to go and take a look at overloading constructors, so that if we didn't provide a full initialization list, maybe we just did a partial initialization list, that our code would still be able to handle that. Our constructors will throw, or will handle whatever we throw at it. So let's take a look now at how we can architect some of these constructors for the class. Now I am going to next share in Xcode. I have got this class already defined. I'm going to go ahead and just zoom in so it's a little bit more visible. And here, this is our typical class header. This is chair.h. I've got the include guards here. Chair underscore h is my constant that it's going to check for. This looks similar here because we've got an int, a bool, and a string. So these represent the number of legs. A Boolean is true if it's a cushion chair. It's false if it's just a flat chair with no cushion. And then, of course, color. Now, in this header file, these should all look very familiar also. Our standard mutators and accessors, sometimes called getters and setters. And I've got inline functions for those. We've covered all those last week in this. You'll note that for my set legs method here, that I don't have an inline function for that. And that's because I want to do some data validation. I want to make sure that the number of legs is set to either 3 or 4, because you can't really have a 2-legged chair, and we're not going to deal with 5-legged chairs. So either 3 or 4. So we need a little bit of input validation there. So that's why there's no inline function beside this set legs. So I have also done a couple of things here too. I have got some constructors prototyped here. Now let's take a look at just the second one for right now. And this is going to initialize then our chair object, provided that we give it an integer, a bool, and a string. Our code then will support that. And I mentioned before that we can overload these functions. As long as they've got a different parameter list, we can successfully overload them. We call them the same thing, and the compiler is going to have no trouble knowing which constructor to use because the parameter lists are different. So if you are going to overload your constructors, and we will be doing a lot of that, make sure that our parameter lists are different. They can be different in the number of terms there are, or in the number of in the data types of those terms. All right, so we're going to first do just the full constructor with the 3 member variables, and we're just going to populate everything. So there's our chair.h. I'm going to go now real quick. I've got this pre-done. I'm going to go to chair.cpp now, which is our implementation. And you'll remember, since I did inline functions, I didn't need to do implementation methods for 5 of the 6 mutators and accessors. I just needed this last one for set legs. So this is where I define it. And I've got just a real quick input validation here. If L for representing legs is less than 3 or greater than 4, then we get the invalid statement. Otherwise, we assign legs to L. Okay, easy there. Now, what I want to look at first is this code right here. This is our constructor that is going to use all 3 member variables, and those come in as arguments. I'm going to call them L and C and CL, L for legs, C for cushioned, and CL for color. And this default constructor is simply going to take whatever value it is and assign it to the member variable. The order is important because this header right here, this method header, has got to match, of course, the order in our prototype up in our class.h file, in this case, chair.h. And then simply whatever is inbound as an argument, we're going to assign that to the member variables. So not too horribly difficult to understand once you kind of get this idea of inbound variables. We're going to set those to the member variables, and we're golden. Now, a thing about constructors is that, first of all, there's no return type ever of a constructor. Yeah, even though it's sort of returning the object, it's not really. So that is why we just simply have chair and then the scope resolution operator and then chair again in our initialization list. So that's our first function, our first method that we can use a constructor on. But look what else I did. I'm going to go back to chair.h, and you'll see that I've got a couple of other constructors also named chair, but the argument list is different. One has nothing, no arguments, and the other is just an integer for the number of legs. So we have to make sure that we define two more methods in our chair.cpp that support that. So let's go first to the constructor that provides no arguments whatsoever. So our header for that is just going to be chair. We've got no parameters listed in the parentheses. And since we're giving nothing, since we're given nothing, it's a very good common practice to go ahead and initialize those member variables to something. So we can initialize legs to 0 and just keep in mind, all right, legs are 0 right now. We created a sort of an empty object with 0 legs, and we'll have to make sure later that we use one of the set functions in order to set the number of legs. Same thing here, I'm just going to set the cushioned variable to false, and then I'm going to set the color variable to the empty string. And then what this does for us is anytime we would just say like chair stool right away gets constructed, it's our object, and it's going to have leg set to 0, cushion set to false, and color set to the null string, to the empty string, okay? All right, similarly, I've got another overloaded construction here that I wanted to write, and that is, well, what if we just give them the number of legs? Well, we can do that as long as our code supports it, as long as we've got an overloaded constructor that's going to just take one parameter, and that's an integer for legs. So here, same thing. We've got an inbound L, and we'll set that to legs. And then we'll go ahead and retain what we did before, keeping this default data. Cushion goes to false, and color goes to the empty string, to the null string. So that's how we would code that overloaded function. That's just going to take one value. All right, so everything's looking good here. It's looking like in Xcode here, I'm not getting any errors. So let's go to our main program now, main.cpp. So here I have got, as my very first task in main, is that I'm going to create 3 chair objects, and I'm going to use a variety of constructors to do so. So I'm going to create a dining room chair, a bar stool, and a footstool. Now, the first object we create is that dining. You'll notice here in line 11 that we are providing no initialization data. So the compiler is going to go, all right, which constructor do I use that, which constructor should I use that uses 0 initialization data? So going back up here to chair.h, it means it's going to pick this one here in line 13. This is the constructor it'll use. We go to chair.cpp. We can see that this then is the constructor that it's going to use, and that we will we'll also see those values then get set to the default values. Here I did barstool, and I'm going to use the full-blown constructor for that, where I'm providing all 3 data elements. And then for a footstool, I'm going to use that third constructor that we created, the one that just does an integer. So if we were to kind of go through this, first, this little section here, first just deals with this dining room chair. So here we created the dining room chair. I've got a little function that I send the object to output the chair, and it just outputs the data. And when we run this, you'll see that, well, if we output the chair as soon as it's created, that it's going to have just its default values. And those default values really won't mean something for us. You know, we can't really work with a chair with no legs. So what I do here in the next couple of lines is to use our getters, you know, our mutators, to set the number of legs, to set the cushion, to set the color. And then finally, we do another output here just to show how that object has changed. So I'm going to run this. We'll ignore the output for now, except for the first part, this dining chair part. And here's our output. And we can see here that the first time we output this dining chair's data, yep, legs was 0, cushioned, we had previously said was going to be false anyway, but color is just 1. I mean, color is blank. So after we set all of these, then we can set those, we put it out again, and then we get the legs. And I've got a little data here. Let's see here. See, get color. All right. Well, it's not showing the color. I'll have to troubleshoot that, but you get the idea here. Then I do something else. I create Barstool. And Barstool is the one that we created the object up here with the full initialization string. So it's got all 3 of them. And you can see here that, it does have legs, true, and green. For some reason, the color here, I'll fix that before I post this data. But then in footstool, this is the one that we created up here just with the number of legs. If we output it, we get, if we output it, we get just 3 legs, but then we go ahead and set these, and then we get the full output there. So that's what is going on with these constructors. A kind of a quick and dirty primer on this. I think some of the tips and tricks all center around keeping track of how different these constructors are and the different types of values that have to get sent to the function when you're calling these methods for the construction. All right, so there's our quick primer. Again, just hope this helps, and then we'll go over these a little bit on Thursday during the tutoring session. All right, and what I'm going to do also then is actually post this code to Canvas, so we'll have that as a resource if you need to refer to how to get these to work. All right, I'll see you later this week, everybody.